Hey guys, welcome back to my YouTube channel. In the last video, we had a look at the Part-3 diagram as well as power sequencing diagram. Today, we're going to be talking about power supply circuit design of our system. But before jumping to that, we are going to recap Part-3 diagram as well as power sequencing diagram once again. Okay, we are now here in our Part-3 diagram. Okay, as you can see here, in this Part-3 diagram, we are using AXP313F, which is power management IC, responsible for delivering these many voltage levels like 0.9 volt, 0.9 volt, 1.5 volt, 1.8 volt, and 3.3 volt. Okay, and at the right bottom corner, we are using BTT regulator, and we're going to talk about this later. Okay, at the right top corner we have DC-DC converter delivering 0.9 volt, okay, for BDT CPU pins of our SOC, and then we have down here DC-DC2 converter which also delivers 0.9 volt for BDT CPU pins of our SOC, and then we have DC-DC3 for delivering 1.5 volt. Okay, this is going to be used for powering off both SDRAM controller of our SoC as well as SDRAM chips, which is a DDR3 in our case. Okay, and then we have ALD D01 1.8 volt, and then DLDO for 3.3 volt. These two are LDOs. Alright, and then this power management IC is powered up with 5 volt DC in. Okay, now let's go way back in our power sequencing diagram. Okay, if we look at this power sequencing diagram, all of these voltage levels are not necessarily for at the same time. Okay, you can see here these two voltage levels 1.8 volt and 3.3 volts are powered up. Okay, some millisecond before these two voltage levels like 1.5 volt up here and then 0.9 volt down here are powered up. Okay, once these voltage levels are steady, the power management IC will generate one signal, which is power okay signal, and this is gonna be our reset signal, which is floated down here, okay, to the whole system. Okay, now let's move over to our power supply circuit design section of our system. So let us go ahead and click on it, power supply circuit. Okay, this is the right one. Okay, here it is, power supply circuit. Okay, as you can see here, we are using AXP313A, in this power supply circuit. So this is the heart of our power supply circuit. Okay, and if we look at the, left top corner of our power management IC, we have 15 pins, which is labeled ALDO, which generates 1.8 volt. Okay, as you can see, these two buck capacitors are connected with these pins, and they are responsible for storing energy as well as filtering out some ripple factors of this power rail. And they are buck capacitor for protecting our power management IC from when it has to be connected to the power hungry devices or so many devices consuming these voltage levels. Okay, and then down here we have the LDO, which generates 3.3 volts, and here also we are not using these two capacitors are connected with this. And this is RTCLDO, and I'm connecting this C8, which is 4.7 microfarad, rated at 25 volts, and it is not mandatory to be 25 volt. Okay, and then 510 ohm. They're connected to these pins. I'm doing this as part of my data sheet recommendation. Okay, and this pin generated 1.8 volt for RT. Okay, and down here these two pins are I2C communications for interfacing with SOC or host. All right, and they are full of, because as you are aware of the I2C communications in this case also they are pull up through pull up to 1.8 volt through these two resistors, 2 kilo ohm. All right, and down here we have IRQ for reset This is IO pins. Whenever the system, the whole system is, in sleep mode, and it has to be, we have to wake it up. Then we use this pin. Okay, and this is normally generated from some external peripherals or, from, uh, you know, from the SOC based on the program execution or based on the, programs or command set image. All right. So this is nothing but power. Okay, like I said before, way back in our power sequencing diagram, you can see this is nothing but the reset, which is plotted down here. As you can see, it is generated only after the, these voltage levels are steady. All right. So this is it. Okay. And then we have power on. Normally it is connected with 100 nanofarad as per the datasheet recommendation. We can also connect like external switch, but our system is some board, so we are not going to connect any external buttons in order to provide a power on through button. And in the carrier board, we can utilize it. Okay. And pin number 8 is for internal reference voltage, and it is recommended to connect it with 1 microfarad to all the way to our ground. As you can see here, it is connected to ground all the way through 1 microfarad. This is just a filtering for our reference voltage, internal reference voltage. Again, this is the data sheet recommendation. All right, so let me zoom in a little bit. Okay, at the right top corner, we have pin, 17 pin. This is nothing but the power input, and we are connecting this to plus 5 volt DC. Okay, and here we have a filter cap, which is 22 microfarad. Okay, and then this is LX1 for generating zero point 0.9 volt, and this is here we have a push pull converter, and it is connected to this 1 microhenry. We can also connect 1.5 microhenry. Okay, at the output of this we have two buck capacitor, and this is again for storing the energy whenever it has to connect so many components or power hungry devices. So these two capacitors protect this IC chip from damaging where when this has to be connected to power hungry devices or too many pins of our SoC. Okay, and once this power will provide the desired voltage levels to the SoC, then the SoC will generate one feedback signal, which is nothing but the BDD CPU feedback. Okay, we are connecting this pins to the DC one. Of this power management IC straight away. Okay, and then down here, the same goes in here also. Like see here, this is B in, which is connected to 5 volt DC, and we have a filter cap which is 22 microfarad, and then we have inductor, okay, and then these two bulk capacitor, and we have a feedback, and this feedback is coming all the way from GPU feedback, and this is for GPU, not CPU. Yeah, all right. And then we have here is B in 3. This is for generating you know uh, 1.5 volt DC, which is responsible for firing up the DRAM controller section of our SoC, as well as the power pins of our DDR3 RAM chips in our case. Okay, good. So down here we have two pins. This 9 and 21 pins. They are nothing but connected to the ground. Okay, and down here we have one BGP regulator chips, and this is also powered up with the same voltage level. The power management IC is powered up, which is nothing but positive 5 volt DC. Okay, and we have one 4.7 microfarad filter caps, and then we have an enable pin. In order to initialize its operations, we need one enable signals, and this is connected to 3.3 volt coming all the way from power management IC. All right, this is in here, okay, 3.3 volt, and it is connected through this 0 ohm resistor. Okay, so far so good. And then we have in here, I mean in the middle, we have power ground, sorry, power good. And this is just for the indication of your I mean good system. I mean it is functioning properly, and this is nothing but the output pin, and it is open run, so it is connected to the BCC. This 5 volt DC to 47K, and we're not gonna use this in our case. Okay, and then BRI, what to say, this is for generating the desire, I mean whatever the voltage we are desiring from these two pins, I mean from these pins needs to be generated, I mean at this point through our voltage divider. Here we are supplying this BDDT temp, which is 1.5 volt in our case, and this is nothing but the voltage divider for generating this voltage. Okay, this is our, I mean, so to speak, this is the just a reference voltage, and this voltage has to be, I mean, this output voltage has to be created from this, generated from this BDDT lamp. Okay, like for example, okay, if I have to use some other voltage levels instead of 0.7 volt, then the whatever the voltage we need here has to be generated at this is nothing but the reference voltage only. Okay, and this is just a sensing pins, voltage sensing pins for proper regulations. All right, and without distortions and whatever. Okay, whatever. And then we again shall also we are connecting this to buck capacitor for storing energy as well as filtering some ripple factors of our power rails. Okay, because this voltage BTT voltage has to be connected to many resistors, I mean ferrule termination resistors in our flyby topology. Okay, so this is it. And okay, so this is all about our power supply system. Okay, so if you have any doubt regarding, please let me know in the comment section.